Good morning, dear student and my friend. Today topic is first law of thermodynamics and the limitation. First law of thermodynamics. It is stated that heat is a form of energy and thermodynamic processes are therefore subject to principle of conservation of energy. This means that heat energy cannot be created or destroyed. It can, however, be transferred one location to another and convert to and from other form of energy. It is a mutually convert. That means work is converted into heat and heat is converted into work. As you see in this picture, that is in that system, this state 1 and this state 2. After applying the heat to this state 1 and work done, so so there is change in state of energy. So that means change in energy, it is called internal energy, that is E2 minus E1 equal to W minus W, Q minus W. ओके, किसी भी सिस्टम को हम जो भी एनर्जी सप्लाई करते हैं, ट्रांसफ़र करते हैं, तो वो किसी अदर फॉर्म की एनर्जी में कन्वर्ट होगा और ये जो एनर्जी है उस सिस्टम की स्टेट को चेंज करती है. ठीक है, तो स्टेट प्रॉपर्टी क्या होती है फर्स्ट लॉ के अंदर? इंटरनल एनर्जी. सो इंटरनल एनर्जी चेंज होती है. सो इंटरनल एनर्जी इंक्रीज़ भी होती है और डिक्रीज़ भी होती है. इंटरनल एनर्जी कब इंक्रीज़ होगा? जब सिस्टम का टेम्परेचर राइज होता है, और सिस्टम का टेम्परेचर यदि डिक्रीज़ होता है तो इंटरनल एनर्जी डिक्रीज़ हो जाएगा. ओके, एनर्जी एज ए प्रॉपर्टी. We see that the system state is the same before and after cyclic process. Okay, if you go through a cyclic process, so initial and final state are same. We assume that both heat and work enter and leave the system. It complete the cyclic process. So from noting that E1 equal to E2, so E क्या है? एनर्जी. E1 equal to E2. So E1 is the sum of Q in and W in. So Q in क्या है? हीट इनपुट. W input. और E2 is the sum of Q out and W out. So we can arrange same side Q in minus Q out or W out minus W in. So it is a summation, and it may be written as cyclic integral del Q or cyclic integral del W for any cyclic process. Transfer del W this left side, that's, and del Q equal to dE plus del W. Okay, del is the inexact differential. It is not a thermodynamic property. It depend on path. And dE, d small d is exact differential. So energy is a thermodynamic properties. So that del Q equal to del W then equal to del E. Okay, it is like that form. So del E is the value of du, and it is kinetic energy, potential energy also equal to 0 for a cyclic process. Okay, so that energy is a property of thermodynamic. Next, the energy balance concept. So एनर्जी बैलेंस मीन्स ये दी एनर्जी कितना आप सिस्टम को दे रहे हैं और कितना उसका एनर्जी चेंज हो रहा है, कितना आउट हो रहा है. सो हम चेंज इन पता करना चाहते हैं उस एनर्जी में कितना चेंज हुआ है. सो चेंज इन अमाउंट ऑफ एनर्जी कंटेंट विद इन ए सिस्टम ड्यूरिंग सम इंटरवल equal to net amount of energy transferred in across the system boundary by heat transfer during time interval minus net amount of energy transferred out across the system boundaries by work during the interval. So this written text in converted in that form, E2 minus E1 equal to Q minus W. So if you give a heat for the system is Q, so it provide work, so there is a difference of this heat and work is equal to E2 minus E1. So E क्या है? It is a summation of kinetic potential and internal energy. A special form of energy balance can be written as from the example of energy balance differential form, dE equal to del Q minus del W. Del is exact differential. It is already proved that energy is a property. So Q and W are not a property because it is an inexact differential. So this equation can be written for a time rate del E divided time equal to uh, Q dot minus W dot. It is the rate of with respect times. Okay, so time rate is basically for a flow process. This equation is valid. Alternative choice for the system boundary. देखिए यहाँ पे हमें एक इलेक्ट्रिक जनरेटर है और एक मास है और ये पुली है. तो जब मास नीचे की तरफ मूव करेगा तो ये इस जनरेटर की पुली को रोटेट कराएगा और जनरेटर क्या करेगा, एक वोल्टेज डेवलप करेगा और वो वोल्टेज कहाँ जाएगा, इस प्लेट कॉपर प्लेट के पास, और कॉपर प्लेट हीटेड होगा तो ये हीट अंदर चला जाएगा. So in this system we have to see that heat is transferred, but work done from the system is zero because there is no work done is interact to the system. Okay, so it is a insulation and it is a system boundary. Okay, in this system the weight is down and this plate doing some work on this gas. Okay, on this. Okay, though there is no heat interaction to this system, so that Q equal to 0, but work is transferred. So in that system del Q or W equal to 0 because we have to assume that it is a whole boundary, it is a system boundaries. So if motor and this subsystem is inside this system, so if heat is comes outside, that heat is come, so we can say that is heat is transferred to the system, but there is no heat interaction from this boundary, so that and also no work is interact, so that Q equal to 0, W equal to 0. So system boundary is defined what is happening of this energy, work and heat. So we have to focus on the boundary of this system, what is happening. Okay, in that system, the system boundary inside that, in that system boundaries out, and so in ABC there is system boundaries differ, so that the value of Q or W is changes. Okay, next, limitation of first law. Most of thermodynamics process is characterized by the direction of constraint involved with them, like heat always flow from higher to lower temperature, current flow from higher to lower potential spontaneously, reverse is not possible instantaneously. So this phenomena of the reverse is cannot be predicted by the first law, so there is a limitation of that law. Okay, next, heat and work are having quantitatively different status. We have know that heat is a low grade energy and work is a high grade energy. So in complete cycle you cannot convert 100% heat to 100% work, even ideal condition. Okay, because the heat is a low grade energy, so low grade is energy converted into 100% high grade energy, it is not possible. So question must comes under ideal condition, what can be maximum efficiency of the heat engine cycle. So first law cannot give any insight to this proposition, so you cannot ever theoretically predict the maximum attainable efficiency of your machine. फर्स्ट लॉ की ये लिमिटेशंस हैं, ठीक है, बस वो तो एनर्जी का बैलेंस तो दिखाएगा, लेकिन कि इस एनर्जी से ये चीज़ पॉसिबल होगा या नहीं होगा इसकी कोई श्योरिटी नहीं होती. सो इस चीज़ को कंप्लीशन करने के लिए सेकंड लॉ फॉर्मेशन हुआ. द फर्स्ट लॉ generally does not give any insight on a absolute thermodynamics temperature scale. What can predict temperatures unreachable in universe? In other words, limit of the temperature scale is beyond the realizing of this law. Next, first law balances energy but compared to ideal efficiency, how efficiency of a system is degrading from ideal, and how to further minimize those losses are beyond the scope of the first law, both quantitatively as well as qualitatively. हम इसमें ऑलरेडी पहले भी इसमें डिस्कस कर किया है कि इसमें जो फर्स्ट लॉ है वो क्वांटिटिवली तो बेस्ट है, लेकिन क्वालिटेटिवली ये कोई रिजल्ट प्रोवाइड नहीं करता है. तो इन लिमिटेशन की वजह से ही सेकंड लॉ का फॉर्मेशन हुआ. सो ये एनर्जी बैलेंस के लिए तो ये बड़ा सही है लॉ, लेकिन कोई एफिशिएंसी निकालना हो और कोई एक्चुअलिटी रियलिटी को चेक करना हो तो इससे कुछ पॉसिबिलिटी रिजल्ट नहीं मिलता है. तो ये इस लॉ की कुछ ये लिमिटेशंस हैं, लेकिन ऐसा नहीं कि फर्स्ट लॉ को यूज़ नहीं करते, लेकिन एनर्जी बैलेंस के लिए तो हम इस लॉ को ज़रूर यूज़ करते हैं. ठीक है, और ये हाई ग्रेड एनर्जी के लिए तो बेसिकली सही है ये लॉ मैक्सिमम. थैंक यू, बेस्ट ऑफ लक, थैंक्स फॉर पेशेंस दिस वीडियो.